Hi, welcome back. We are going to talk about these magical things called conic sections today. And I'll explain what these things are. But there's four different ones. We are going to talk about the easiest one today, which are circles. So, what you're going to learn is how to find the center of a circle and the radius of a circle. And I go, Barton, I already know both of those things. You don't need to insult my intelligence. All right, I'm not insulting your intelligence. I'm going to make it hard enough that your intelligence is not insulted. And now you're thinking, wait a second, I didn't say that. Hold on, Barton, I don't want this to be difficult. You know my three greatest fears in life are fractions, doing things that are difficult, and chihuahuas. What are you thinking, Barton? How dare you? I know. Don't worry, there's no fractions and there's no chihuahuas today. But things are going to be a little difficult. But that's what makes us better people, so we're going to struggle through this together. So let's go talk about some vocabulary first, and then we will learn about circles. All right, so just in case your, kindergarten teacher never told you what a circle is, a circle is the shape made by graphing all the points that are equidistant from another fixed point. So let me just illustrate. I'm going to draw a circle and you're going to be like, I know it's a circle, Barton, but let me just show you what I mean. So if here's our fixed point, check this out. I love these. I never get to use these. So let's insert a compass. Check this thing out. You can stick the center right there and then you move that thing out. So right now, this compass is that far away from the center. Here you go, okay, obviously. So if I take this thing and I spin it around, this distance between the pointy tip and the pen tip are going to stay the same the whole time, right? Like you put a big lock on this thing, right? What do locks look like? Something like that? I don't know. Right? You lock this thing, fix it in place, and then spin it. So let me see if I can do that, actually. This is going to be tight. Watch this. So we spin it. This distance is not changing. It's always the same distance between the pointy tip and the pen tip. So these are all the points that are the same distance away from the center. Okay. I mean, I'm not trying to insult you here. I understand you know what a circle is, but it's just, it's important to realize how this is made. I know you know that it's made with a compass, but never mind. You're right. I'm dumb. I don't know why I even taught you that. Sorry. Didn't mean to insult you. But you get what I mean. It's important to realize the math definition because someday you guys are going to grow up, go to college, and go, you know what? Maybe Barton was right. Maybe I should be a math major. And then you're going to study math for the rest of your life, right? Heck, English. I don't need to learn no stinking English. Spellings for chumps. I don't need to write poetry unless it's about math. All right. So now let's talk about what a conic section is. So the word conic just comes from the root word cone, right? This is like the adjective version of the word cone. It's a conic section. So what that means is it's a shape made by cutting a cross section from a cone. There are four of them. So here are some wonderful pictures. I think I stole these from Wolfram Alpha. Don't Google that. You don't want to know what Wolfram Alpha is. So basically, these are 3D cones, right? You're not looking at them straight on. If you looked at them straight on, they'd look like this, right? They're kind of tilted towards us, so we can see the top comes down to a point, goes down to another point, cone, right? It's 3D. And they draw the little like back line so you can see that. So we're looking down on it from up here. The way you get your conic sections, the four of them, is by taking a plane. So you take basically like a piece of paper, right? And then you slide this thing through the cone and slice it. And then you look at what shape the slice is. So what we're going to look at today is if we have a piece of paper that looks like this, that's just perfectly flat, and we slice our cone like that, what you're going to get is the place where this cone intersects this plane is going to look like this. And you get a circle. Cool, right? If you look straight down on a cone, this is a top-down version of a cone, right? You see circles. So if we take slices of this thing, you're going to get cones. Or not cones, circles. So we're looking at a perfectly flat slice of a cone today, and we're going to get circles. We will talk about these other ones, parabolas that you're familiar with. These are like x squared things. We're going to talk about ellipses, which is a fancy word for ovals, but they're like special ovals. They're not just arbitrarily made ovals like you did in like kindergarten. They're special ovals. And then we will talk about these things called hyperbolas, which kind of look like parabolas, but not 100%. They're conic sections. They're both made in a similar way, but they're not quite the same thing. So we're going to learn those 4 different conic sections over the course of this unit, and we're going to start with the easiest one, which is a circle. All right. Let's look at the equation of a circle, break this thing down so you know what everything is and where to look for specific information, and then we'll go do an example. We'll take a slight detour. We have to go walk through a park first to realize that we know a lot more math than we think, and then we'll do a hard example. So, just like most other equations, we can have circles with transformations, and the way we transform them is with an h and a k value, just like we have something like y equals x minus h squared plus k. And this is our horizontal shift, this is our vertical shift. These h and k's do the exact same thing that these h and k's do. So this h is going to actually be the horizontal location or the x value for the center of our circle. So if we have something like x minus 3 squared, then h equals positive 3. Remember, this negative is part of the equation, so we just want the number, so 3. So you're going to change the sign. That means somewhere on our graph over here at 3, our circle is going to be somewhere lined up with that. K, for circles and hyperbolas and ellipses, is actually kind of backwards from the way we've always seen it. Normally we think of k as just being whatever number we see right here, but that's because it's always plus k. In this equation, and hyperbolas and ellipses, we have minus k. So that means for circles, k is reversed, just like h is reversed. So if we see something like plus y minus 4 squared, then k equals positive 4, and we need to flip the sign. And the reason for that is because it's inside this math operation in the parentheses with the h. Anytime you're putting your transformation inside a math operation like this, it gets flipped. So that's why this is backwards. So this circle right here would have a center at 3, 4, so it'd be right there. All right. This is the thing that makes the circle, equals our radius squared. The most important thing to remember is that this is the radius squared, not just the radius. So if you see something like equals 9, our radius is not 9. It's whatever the square root of that number is. This is the radius squared, so they've squared whatever your radius is. So to get back to just the radius, you have to take the square root to cancel out that. So our radius would actually be 3. Okay. And then, I mean, it's easy to do from there, right? You just circle. Oh, that looks awful. All right, luckily you don't have to draw circles. You just have to identify them. But so there we go. H is the horizontal shift. It tells us the x location of the center. K is our vertical shift. It tells us the vertical location of the center. Both are sign swapped from the equation. And then this tells us our radius squared. So to get to the radius, we have to take a square root to figure out the actual radius. All right, let's go look at a little easy baby example. Right, we're going to start you easy. This should be something you remember from kindergarten. If it's not, go back and give your kindergarten teacher a piece of your mind. Listen, I was unprepared in high school because you didn't tell me this. Could you imagine? That would be so funny. Anyway. All right. So it says find the center and the radius. So we want to, let's see, how do you spell center? Not like that. Center, radius. All right, we need to find these two things about whatever circle is described by this equation. So we need to find our h value, we need to find our k value, and we need to find r. H is inside the parentheses with x, but we have to flip the sign because it's reversed, because it's inside the parentheses in a math operation. So because this says -3, h is +3. Same thing with k. It's inside the parentheses with the y value, and we have to flip the sign. So because this says +5, k is -5. And these two numbers tell us the location of our center. It's at h comma k. Good mathematicians don't say comma, but I'm not a good mathematician. So it's going to be at 3, -5. To find our radius, we need to look at this isolated number on the other side of the equal sign. And remember, this is the radius squared. So to find just the radius, we have to take a square root. So the square root is 4. And I know, you guys are those nitpicky honors kids, right? And you go, but Mr. Barton, when I take a square root, I have to say plus or minus 4. The radius is a measure of length. You can't be -4 something long. You can't be -4 feet tall. You can't travel, let's not get into it. You can't be -4 feet tall is all I'm trying to say. So we don't really care about the negative because it doesn't make real life physical sense. So we just ignore that, right? Just get rid of the negative because circles can't be -4 wide. So our radius is 4. And there you go. That's your homework basically, is given this thing, where's the center and what's the radius? And that's all you have to find. You're gonna go, Barton, this is easy. How could you possibly think that me of all people, could need another example? Don't make me scoff, Barton. Well, hold on to your britches, kid. We're gonna make this more challenging so that you don't have to scoff. All right, we're gonna take a little detour though, and we're gonna investigate this thing, because you're gonna need to know about something called completing the square. Okay, and this is one of the most dreaded things that you learn in Algebra 2 because it's complicated and you get fractions. So, so let's look at this kind of easy example here. We're gonna do some foiling stuff out, and then we're gonna go back and relearn completing the square because we're gonna need that for some circles. All right, so let's go ahead and FOIL out x minus 3 squared. So that'll be x minus 3 times x minus 3 equals 5. So we're gonna do our distributing. So x times x is x squared. X times -3 is -3x. -3x times x is another -3x. And -3 times -3 is +9, still equals 5. If we simplify this by combining our like terms, we have x squared minus 6x plus 9 equals 5. All right, and just because usually we like stuff to equal 0 so we can punch it to death with the quadratic formula or something, let's move the 5 over. -5 minus 5, those cancel, and we have x squared minus 6x plus 4 equals 0. All right, so let's take some time, make some observations, and then see if we can take this thing and get back to our original equation. In fact, I'm going to erase all this work so we can't cheat and look at what we did. Actually, let's undo that. I do want to take a slight detour and look at this step here. So let's erase all this stuff. All right, so some important things that you need to recognize. This number and this number are very much related to that number you are adding or subtracting inside the binomial squared. This number in the middle on the coefficient is 2 times whatever that number is. So because this is a -3, this is a -6. If we did x plus 4 squared equals 7, if I FOIL this out, this could be x squared plus 8x, because this is just this number doubled. This last number here is whatever this number is squared. So -3 times -3 is +9. What's nice here is when you square stuff, it always becomes positive. So you don't have to think, is this +9 or -9? It's always going to be positive. Same thing here. If we took this without having to really think too hard, we know that this last number has to be this number squared. So it'd be +16 equals 7. All right. So we want to be able to take this thing and get back to that thing. We want to force it to be a perfect square. So how are we going to do that? The secret is kind of captured right here. This is where we need to focus our attention to be able to reverse this process and figure out what was that thing we had over there and what goes in this parentheses. This 9 gets messed up when we bring the 5 over, right? I can't really tell that this was a 9 and a 5. It's just a 4 now. I don't really get where that came from. But after the foiling process, this -6x is untouched. So what we're going to do is we're trying to get this back to x and something squared equals a number. We can figure out the thing here by taking half of this number. So -6 divided by 2 is -3. You with me so far? Cool. And now you're going to say, all right, but how do we get that number, right? It's mixed up with that 9 and the 5. How do I turn this 4 back into a 9 and a 5? How do I figure that out? So I've actually gotten a tiny bit ahead of myself. If we have x squared minus 6x, we want to separate these out too. So we're going to go equals. We don't know what that number is, and we don't know what this number is. We can figure out this number because it's this number squared, right? So we take half of this, get -3, then we square it, and we put a 9 here. Okay, +9. All right, now we think to ourselves, how do we turn a 9 into a 4? Because it still has to be 4, right? So 9 minus 5 would be 4, and then we just move the 5 back over. Okay, and this is pretty much completing the square at that point. So we're going to figure out what are these numbers, and then we're going to use this and this information to get back to our 5. All right, so let's go look at an actual example of this, and then we'll see how you're doing. So here's the complicated circle question. It says, find the center and the radius of the circle given by this equation here. All right. So we have x squared plus y squared plus 8x minus 14y plus 56 equals 0. We need to turn this back into x minus h squared plus y minus k squared equals r squared. So the first thing we want to do on this is we want to group together our x terms and our y terms, and then we're going to do some fancy stuff to this 56 here. So let's rewrite this, grouping together the stuff we know should go together. So we're going to have x squared plus 8x. I'm going to put plus blank here, put a little placeholder that we're going to need in a second. Group together our y terms, plus y squared minus 14y plus blank. I'm going to bring down this plus 56, and that's going to equal 0 still. All right, now we need to figure out how are these going to factor? What are these binomials they're going to turn into? So finding the binomial is really easy. We just take half of whatever that coefficient on the linear term, and that'll tell us the number that goes in the binomial. So for the x's, this is going to factor to x. Half of +8 is +4 squared. All right, plus, whoops, I probably should make that red. Let's make it purple for unimportant stuff, right? That plus is just because there's a plus sign in the middle of the equation. Oops. Now we have to do the same thing with the y's. We have to factor it into a binomial squared. That's going to be y, and then half of this number. So half of negative 14 is negative 7 squared. All right. So now you're going to say, Barton, look, we've got everything, except that radius squared. So we have to figure out this radius. To do that, we need to figure out these two numbers here and somehow pull them from somewhere. So to figure out this number here, it's this number in the binomial squared. So 14, not 14, I misspoke. 4 squared is 16. And negative 7 squared is 49. All right. So this doesn't quite give us our radius yet. But what we're going to do, we just added a 16, and there's not a 16 in here. So we made up this number. We're putting 16 in here. And if you just add 16 arbitrarily, you're changing this formula. So we can't add the 16, we need to take it from somewhere else. If only we had a big stack of numbers just sitting around we could pull from. And that's exactly what we're going to do. We're going to pull these numbers from this number. So if I have 56 things and I need 16 over here, I'm going to take away 16 from this pile and put them in this pile. So 56 minus 16 is 40. All right, so now I have 16 here and 40 here. Now I need to take 49 out of my pile and put them over here. And you go, Barton, you can't take 49 things from a pile of 40. That's not possible. That's because you guys are thinking about real life. And this isn't real life. This is mathematics. So we can do not whatever we want, but we can take 49 things from 40 things. So if I'm taking 49 and putting them here, I need to take 49 out of this. So we're going to subtract 49, and we get negative 9. Wonderful. So I've taken my 16 and put it here. This thing factored to this. I've taken 49, put it here. This whole chunk factors to this. And now what we have left over is negative 9. So to get your r, all you do is take this leftover little chunk and we move it to the other side of the equation where the 0 is. So to move anything across an equal sign, we have to do an inverse operation. So we do plus 9, plus 9. So this is 9. And now this is back in our more standard form. Technically, this is the math vocabulary standard form. I believe this is called either vertex form or like center form, something to that effect. Now that we have this factored and we have our number moved back, we are all set to find our center and our radius. So our center comes from h and k. H is negative 4 because we flipped a sign. K is positive 7 because we flipped a sign. And r is the square root of this number. So r is 3. So our center is at negative 4, 7. And our radius is 3. All right. This can be a daunting process because completing the square is not the most intuitive thing in the world. So what you want to do is, let me try and write some steps here. You want to start by grouping variables. So put your x's together. Put a little space where we're going to fill in later. Group your y's together. Put a little space holder that we'll fill in later. All right. Then you want to factor this kind of already knowing what you want the answer to be. So all you have to do is divide by 2 to get that number. Divide by 2 to get that number, and then we have our binomials filled in. So this is fill in binomials by dividing by 2. Then we have to go backwards. We have to fill in these 2 blanks we had. You just square those numbers we found and fill them in. So we're going to square binomial numbers to fill blanks. Okay. And then we need to think of filling in those blanks as pulling out of our repository. We need to pull those numbers out of the stack of numbers we have laying around. So once you figure out these numbers, we subtract them from that constant at the end. And then once we've subtracted out both of our numbers, move the remaining bit to the other side of the equation. Okay. So pull blank from constant by subtracting. Then move the remaining amount over. All right. If you need more help with this, of course, I am here to support you in any way that I can. Please join the WebEx. Say, hey, Mr. Barton, I really need your help with this. I'm just not remembering completing the square. It's a very challenging process, and you're going to have to bear with me. Learning online is difficult for everyone involved. And I am here to support you in any way that I can. So feel free to ask questions. If you need another example, let me know, and we can go over some of your homework together. Until then, have a wonderful day, my beloved students. Stay out of trouble.